Welcome. In this video, I'll be showing how to use the mean to z standard normal tables to calculate normal distribution probabilities. I will also be showing software formulas along the way. Note that the table we'll be using in this video is the mean to z table. That is, the areas provided in the table are 0 to z areas under the curve. A normal distribution is a symmetric bell-shaped distribution where the total area under the curve is 1 or 100%. Because it is symmetric, the mean and median are equal and are at the center of the distribution. It means if we cut it in half at the center, we will have 50% of the area below the mean and 50% above the mean. The standard normal distribution, or what is also called the z or z distribution, is the standardized normal distribution with a mean mu of 0 and a standard deviation sigma of 1. The formula for transforming a score or observation x from any normal distribution to a standard normal score is z equals x minus mean over standard deviation. The standard normal score, also known as the z-score or z-value, is the number of standard deviations a score x is from the mean. Again, the standard normal tables we'll be using is the mean to z table. This table contains areas or probabilities from z equals 0 to the specified z-value as shaded under the curve here. This table comes in positive z-values only. To obtain areas for negative z-values, we will use the same table and apply the symmetry property of the normal distribution. In the first column here, we have the first decimal place of the z-score, and at the top, we have the second decimal place. For example, if we want the area between z equals 0 and z equals 1.32, we will go to 1.3 in the row here and 0.02 in the column. So the area is 0.4066. Now, because of symmetry, the area between z equals 0 and z equals negative 1.32 will be found in the exact same way, and it will also be 0.4066. However, if we want the probability that z is less than negative 1.32, that is the probability of this lower tail, we will subtract this area from 0.5 since the total area below the mean is 0.5. So this less than area will be 0.5 minus 0.4066, which gives 0.0934. But if we want the probability that z is greater than negative 1.32, we will add 0.5 to this area to obtain 0.9066. Now, note that the normal distribution is a continuous distribution, so there is no distinction between z greater than negative 1.32 and z greater than or equal to negative 1.32. They are treated the same way. Furthermore, if we want the probability that z is between negative 1.32 and positive 1.32, we will add the two areas or double the single area to obtain 0.8132. Now let's consider further examples. Scores on a test are normally distributed with a mean mu of 70 and a standard deviation sigma of 7. We want to find the probability of obtaining scores in the intervals listed in A to D below. In A, we want the probability that a score x is less than 84. So for x equals 84, the corresponding z-score is 84 minus 70 divided by 7, and that gives z equals 2 or 2.00. Now on the z table, we look up z equals 2.0 under 0.00 to obtain an area of 0.4772. That is, the area from z equals 0 to z equals 2 is 0.4772. Therefore, this shaded area is the area we found in the table. However, the probability that x is less than 84 is the probability that z is less than 2, which is the total area below z equals 2. Since the area to the left of the center here is 0.5, the total area below z equals 2 is 0.4772 plus 0.5, which gives 0.9772 or 97.72%. For part B, we want the probability that x is at least 84. Recall that the normal distribution is a continuous distribution, so there is no distinction between x is at least 84 and x is greater than 84. We apply the same approach in both cases. Also recall from our previous calculation that when x equals 84, z equals 2. So we will be correct in saying that the probability that x is greater or equal to 84 is equal to probability that z is greater than 2. And one way to find this greater than probability is to subtract the less than probability from 1. If we don't have the less than area, since the area above the mean is 0.5, we can do 0.5 minus 0.4772 to obtain 0.0228. In part C, we want the probability that x is between 60 and 74. For x equals 60, z equals negative 1.4286, which becomes negative 1.43 when rounded to 2 decimal places. We have to ensure we round correctly to 2 decimal places if we're using the table. Also, for x equals 74, the standard normal score is 0.57. Recall that we do not have the negative z values on the mean to z table. Therefore, for z equals negative 1.43, we will look up 1.4 under 0.03, which gives 0.4236. It's the same area from 0 to negative 1.43 because of symmetry. Similarly, for z equals 0.57, we'll look up 0.5 under 0.07, and that gives 0.2157. Thus, the probability of obtaining a score between 60 and 74 is found by adding these two areas, and that gives 0.6393. Finally, we find the probability of a score lying between 74 and 84. When x is 74, z is 0.57, and when x is 84, the z value is 2. The area between 0 and 0.57 is 0.2157, and the area for 2.00 is 0.4772. The required probability is the area between the two z-scores shaded in blue here, and it can be obtained by subtracting the smaller area from the larger area, and that gives 0.2615. In summary, to find the area from z equals 0 to any z value in the mean to z table, just look up the area in the table, and if you have a negative z value, the area from 0 is the same as the area for the positive z value due to symmetry. You can also obtain the area in the tail of the curve, whether for a negative or a positive value of z, by subtracting the 0 to z area from 0.5. If you want the area above a negative z value or below a positive z value, then add 0.5 to the area in the table. Next, if you want to find the probability or area between a negative z and a positive z value, then simply add the two areas obtained directly from the 0 to z table. If you want the area beyond them, then subtract this total area from 1. Finally, if the two z values are on the same side of the center, that is, either both positive or both negative, then subtract the smaller area from the larger one. Note that we only add or subtract areas. We do not add or subtract z values. Note also that you cannot obtain a negative area. Areas or probabilities have to be between 0 and 1 or between 0 and 100%. And that's it for this video. Thanks for watching.